so welcome to this video on momentum physics. In this video, we're going to be looking at momentum physics problems and solutions. So we're basically going to be solving random questions involving momentum physics in this video. So in the previous two videos, we've introduced momentum, solved good examples of momentum, but this video is basically to just solve lots and lots of problems that could be expected in momentum. Alright, so let's start with the first question. It says, a constant force of 5 Newton acts for 5 seconds on a mass of 5 kg initially at rest. Question says, calculate the final momentum. Now let's pick out our parameters. We are given that a constant force of 5 Newton, so force F, given force is equal to 5 newtons, okay? Now acts on a mass of 5 kg, so we're given mass. We're given mass M to also be 5 kg. Initially at rest. So acts for 5 seconds. We're also given time 5 seconds. Time T was given as 5 seconds. Now we're asked to find the calculate the final momentum. So in the first video, I explained that impulse, which is force times time, is equal to the change in momentum, which is m multiplied by v minus u, which symbolizes change in momentum. So you can simply say impulse, force times time, is simply equal to what? Change in momentum, p, where p stands for momentum. So it means that impulse is same thing as change in momentum. So all we need to do in this question is what? Multiply the force by the time of action. That gives us the final momentum. So this simply implies that final momentum P becomes what? Force 5 newtons acts within a time frame of 5 seconds. So 5 times 5, this simply gives us what? 25 kilograms meter per seconds, and this is the value of the change in momentum. So to watch the very first video, because I explained this in the first video, I'll be dropping a link in the description of this video, so you can simply click on it to watch it for proper understanding. So always keep in mind, impulse can also be likened or is simply taken as momentum. Now let's move on to the second question. So let's consider the second question. Question says, when taking a penalty kick, a footballer applies a force of 30 newtons for a period of 0.05 seconds. If the mass of the ball is 0.05 kg, calculate the speed with which the ball moves off. Now let's pick our parameters. We're given that when taking a penalty, a footballer applies a force of 30 newtons. So given force F was given there as 30 newtons. Okay. Newtons for a period of 0.05 seconds. So our time was given given time T is given as 0.05 seconds. If the mass of the ball is 0.075, so mass was given m equals 0.075 kg. We're asked to find the speed with which the ball moves off. So once again, we also employ the Newton's second law as applicable to momentum. Just like we did previously, impulse, which is force, times time, is equal to what? The change in momentum, mass times velocity. Simple. So we have to find what? The velocity. Now what is force? From the question, force there is 30 newtons. multiplied by time is 0.05 seconds. This is equal to mass of the object is 0.075 multiplied by velocity v, which we are looking for. Alright, so 30 multiplies 0.05. That simply gives us 1.5. So we have 1.5 to be equal to 0.075 v. So we simply make v subject. This implies v becomes 1.5 divided by 0.075. Okay, so if we do that, we are going to have v to be equal to divided by 0.075. That simply gives us 20 meters per second. So it means that the object moves off with a speed of 20 meters per second after the kickoff. Alright, so let's go to the next question. Alright, so let's consider the third question. Keeping in mind these questions are also should also be expected in the JAMB examinations for those in Nigeria. Okay, the previous question and this one should also be expected in the JAMB examination. Now the question says a body of mass 200 grams moving with a velocity of 20 meters per second collides with a wall. If after collision it moves with a velocity of 4 meters per second in the opposite direction, calculate the change in momentum. So let's pick out the parameters. We're given a body of mass 200 grams, so mass m was given as 200 grams. So learn to convert your mass to kilograms. Dividing 200 by 1000, that gives us 0.2 kilograms. Okay, moving with a velocity of 20 meters per second. So velocity v is 20 meters per second. Okay, so this velocity is the initial velocity, so let's call it u instead of v, right? Let's call it u instead of v. So initial velocity u is 20 meters per second. Now if it collides, okay, it collides with a wall, so let's find momentum before collision. Momentum before collision is simply by multiplying these two together. Momentum before collision so you multiply the two together, call that P1 equals mass times velocity. Mass is 0.2, velocity itself is 20. This will simply give us 0.2 times 20. That simply gives us 4 kilogram meter per second. So we have 4 kilogram meter per second. Now if after collision it moves with a velocity of 4 meters per second in the opposite direction, so mass, so speed after collision, or velocity, final velocity in this case, now final velocity, this is after collision, call that v is equal to 4 meters per second. Okay, 4 meters per second. Not forgetting the mass remains the same. Mass is unchanged. Mass remains 0.2 kilograms. So we can now find the momentum after collision. So momentum after collision okay, call that P2 is going to be equal to mass times velocity. So mass is 0.2, velocity now is 4, this will simply give us approximately 0.8. So we have it to be 0.8. 0.8 kilogram meter per seconds. Now the question is saying calculate the change in momentum. Change in momentum simply means the difference between the initial momentum and the final momentum. Therefore, change in momentum delta P is simply going to be P1 minus P2, and this is going to be P1 is 4 minus P2 is 0.8, and this simply implies change in momentum is now going to be equal to 4 minus 0.8. That gives us 3.2 kilogram meter per second. Alright, so this becomes the change in momentum during collision, before and after collision. So let's pick the fourth question. Alright, so let's consider the final question for this session. The question says two balls A and B of masses 3 kg and 4 kg and moving with a velocity of 8 meters per second and 9 meters per second respectively collides with one another. After collision, the two balls move off at the same velocity. Question says calculate this velocity. So let's give a pictorial diagram. That's how I love to solve my momentum questions. We have two balls, ball A, and we have ball B. Okay, now ball A is moving with a speed or with a velocity of 8 meters per second. Let's say to the right. Direction was not indicated, so let's simply say to the right. So we have 8 meters per second. The mass of ball A was also given as 3 kg. So the mass of this ball is 3 kg. Ball B was moving with a speed of 9 meters per second. Direction also not indicated, so let's say they are moving opposite one another. So the speed is 9 meters per second and its mass is 4 kg, 4 kilograms. So in this case now you observe that ball B has a higher mass than ball A, so which means after collision the two balls will move in the direction of ball B. Alright, so the first thing to do is to find the total momentum before collision. So momentum before collision let's simply call that P1. That becomes the sum of the momentum of the two objects. So momentum of A becomes mass times its velocity, and mass of A is 3 times velocity of A is 8, plus, for the fact that ball B is moving in the opposite direction, it means that its momentum will be negative, right? So we have minus 4 times 9. So this is equal to 3 times 8 is 24 minus 4 times 9. Let's see what that value gives to us. 4 times 9 gives us 36. So minus 36. So this simply implies that the initial momentum P1 will be equal to negative 12. That simply gives us negative 12 kilogram meter per second. Now, the question says After collision, the two balls move off with the same speed. So after collision, let's give a pictorial diagram to represent that. So after collision, obviously, since the mass of block B or ball B is larger than that of A, it means the two balls will move in the direction of B. Okay, so they move off at the same speed, so which means they collide and they move off at the same speed. This is ball B, and that speed is actually unknown, so we call that V. Mass of A remains 4 kg, right? Let's confirm, please. Mass of A is 3 kg versus 4 kg. So mass of A remains 3 kg, and mass of B remains 4 kg. So now we find total momentum after collision. Momentum after collision, we call that P2 simply. This is going to be equal to the momentum of ball A is 3 times V plus momentum of ball B is 4 times V. And simply because both of them now move in the same direction, you simply add their momentum. So this will be equal to 7V. Now I want you to keep something in mind. If you observe, when we consider before collision, ball B was moving to the left. For that reason, we consider it to be negative because it is opposite the direction of A, which is moving to the right. Now, since ball B has a higher mass than ball A, the two objects now move to the left altogether. So it means since these two objects are moving to the left, we are also going to be considering the left to be what? Negative. So it's more like saying negative 3V, negative 4V. That gives us negative 7V. So we should be attaching a negative sign here. Okay, so you can easily rewrite that. Okay, you can easily write that P2 equals negative 3V minus 4V, because the two objects are moving to the left, and when it is moving to the left, it is considered to be negative. Alright, so that gives you negative 7V, because that is the way we can be able to eliminate this negative sign on the first momentum and obtain a positive speed. Alright, so from the principle of conservation of linear momentum, momentum before collision, P1, must be equal to the momentum after collision, P2. Alright, so that simply means, you recall, P1 must be equal to what? P2. So this simply implies P1 itself is negative 12, and this is equal to negative 7V. So from here, you make V subject, that becomes negative 12 divides negative 7. So let's obtain the final speed. So negative 12 divides negative 7, that gives us 1.71 meters per second. So the final speed is simply 1.71 meters per second. So this becomes the common speed between the two objects when they move in the same direction. Mind you, you can as well use the positive 7 to solve. In that case, you have a negative speed, which also tells you that what the objects are moving to the left. So in whichever way you use, you're going to be correct. Alright guys, so that's it on momentum. We've done 3 videos so far on momentum, and I'll be posting all the links in the description of this video. Do well to watch it all for proper understanding. In the next video, we are going to be looking into work, energy, and power, and as usual, we are going to be backing up all our explanations with multiple solved examples. I hope to see you in that video. Do well to like this video, share to your friends, comment nicely, and if you're new to the channel, do well to hit the subscribe button and turn on your notification bell so you don't miss out on our subsequent videos. I will see you in the next video. Thanks.